We'll start in 1 minute. Today we're going to cover section 9.5 on applications with quadratic equations. We'll have quiz 9 on Friday. So for quiz 9, review how to solve quadratic equations using a valid method. If by chance you can solve by factoring, that's perfectly fine. If you want to use the completing the square method, you can always use that method. And then there's always the quadratic formula. So use any one of those that will work. Just remember that not all quadratic expressions can be factored with integer coefficients. And so you can always use the completing the square method or the quadratic formula. And the quiz will be Zoom proctored, and we'll start it at about 8:40 a.m. on Friday. And that should be enough time to finish the problems on that quiz. Okay, in section 9.5, applications with quadratic equations. There's a general problem-solving strategy that we can adopt here, but it also works in other settings. So read the problem, and the more that you understand about the words and the ideas in the problem, the better off you are. So try to understand the problem as much as you can. Identify what needs to be found. Usually that's pretty obvious if you look close enough, what needs to be found. And then pick a variable to represent each quantity that needs to be found. Sometimes you can just use the same variable for two different quantities, because oftentimes we're told how two quantities relate. And I'll point that out when we're doing the problems. Using the variable assignments from step 3 and the given information, formulate an equation. And we've had experience doing this with other types of problems. Then solve the equation using algebraic properties. Don't try to invent a new method. Just use the methods that we know about. And then you can always check your answer and verify that it makes sense. Okay, so we'll look at our first problem. So this is just an exercise on how to set up an equation. This one says the product of two consecutive positive odd integers is 143. Find the integers. Okay, consecutive odd integers differ by 2. For example, 7 and 9 are odd integers, and they're consecutive because the odd integer 9 comes right after the odd integer 7. So they differ by 2. So we can pick x to be one of those and x plus 2 to be the other integer. They differ by 2. And this is what I was referring to earlier. We're trying to find two quantities, but we're using the same variable. X is one of the integers, and then the next odd integer after that is x plus 2. Okay, so now we'll use the information, using the variable assignments and the information given, we're told that the product of those two integers is 143. So product means we're going to multiply the two variable expressions, x times x plus 2. This is the product, and we're told that the product is 143. Okay, so this is just a quadratic equation. It's not in standard form, but we can get it into standard form. Multiply x times x plus 2, we get x squared plus 2x equals 143. And then subtract 143 from both sides, we get x squared plus 2x minus 143 equals 0. Okay, so we can use any method that we want to solve this. I'm going to use the completing the square method, but if you would rather use the quadratic formula, you can. But I'm going to use the completing the square method. I'm going to add 143 to both sides, so I could have just started with this one. Okay, then we're going to add a number to both sides so that the left-hand side is a perfect square trinomial. I should point out that the coefficient of x squared is already 1. If the coefficient of x squared is something other than 1, we have to divide every term on both sides by that. And now we can complete the square on the left-hand side. We would take 1/2 of 2, 1/2 times 2, that's 1, and then we're going to square that number. 1 squared is 1, so that means if we add 1 to both sides, x squared plus 2x plus 1 equals 143 plus 1. The left-hand side is now a perfect square trinomial. So it's equal to the binomial x plus 1 squared. And the right-hand side, 143 plus 1, is 144. And now we can apply the square root property. Since x plus 1 quantity squared equals 144, we write x plus 1 equals positive and negative square root of 144. The square root of 144 is just 12. So x plus 1 equals positive and negative 12. This quadratic equation has two solutions. So we'll subtract 1 from both sides and write it as x equals negative 1 plus and minus 12. Okay, the quadratic equation, one solution is x equals negative 1 minus 12, or x equals negative 13. The other solution is x equals negative 1 plus 12, or positive 11. Okay, but in our problem, we want the two integers, the two consecutive odd integers, to both be positive. So we're going to only use our positive solution, x equals 11. Okay, so one of the numbers is x is 11. The other, x plus 2, is 13. And so the solutions to this particular problem are positive 11 and positive 13. And then one of the steps in the problem-solving strategy, just verify that these are the correct answers. These are consecutive odd integers. They're both positive, and the product, 11 times 13, is 143. So everything checks out the way that it should. Okay, we'll move on to the next problem, number 2. This one says the area of a triangle is 136 square feet. The base is 2 feet longer than 4 times its height. So this word "the" shouldn't be there. So the base is 2 feet longer than 4 times its height. Find the base and the height of the triangle. Okay, for triangles, what you have to know going into this is that for any triangle whatsoever, you can always assign one side of the triangle to be the base, and then there's a corresponding height. And then the area of a triangle is 1/2 multiplied by its base. I'll write out the words: 1/2 base times height. This is true for all triangles. Okay, so we're told that the area of a particular triangle is 136 square feet, and we're told how the base and the height are related. So since the base is described in terms of the height, the easiest thing, in my opinion, is to assign a single variable for the height. And then since the base is described in terms of the height, we can describe the base in terms of x, which we have assigned to be the height. Okay, so the base is 2 feet longer than 4 times its height. Okay, so 4 times the height is 4x. And if it's 2 feet longer than 4 times x, then the base is 4x plus 2. Okay, then we use the area of a triangle formula. We're given the area is 136 square feet. So we replace the area in this formula with 136. And that's equal to 1/2 times the base, 4x plus 2, times the height. This equation is just a quadratic equation. It's obviously not in standard form, but we'll get it into standard form. Okay, from here we have a couple of options. What I would prefer to do, if I were going to do this, I would first multiply 1/2 times the binomial 4x plus 2. Another option is just to multiply both sides by 2. Either way is fine, but to me it seems more efficient to just multiply 1/2 times the binomial 4x plus 2, and we'll still have a binomial. It'll just be 2x plus 1, and then times x. Then multiply the binomial 2x plus 1 times x, so we get 136 equals 2x to the second plus x. And then we can write this quadratic equation in standard form if we subtract 136 from both sides. So we get 0 equals 2x to the second plus x minus 136. Okay, well, it might not be that fun to use the completing the square method on this one because it involves fraction arithmetic. It can still be done, but let's use the quadratic formula on this one. Okay, this is in standard form, so a is 2, b is 1, and c is negative 136. Okay, so we write x equals negative b, which is negative 1 this time, plus and minus the square root of 1 squared minus 4 times 2 times negative 136, all divided by 2 times 2. Okay, so we'll do a little bit more arithmetic. We get x equals negative 1 plus and minus the square root. We have 1 squared, which is 1, and then minus 4 times 2 times negative 136. We're subtracting a negative, so that's equivalent to adding a positive. And so we're going to add 8 times 136. So for now, I'll just write 8 times 136. And then we're dividing this all by 2 times 2, which is 4. Okay, so 8 times 136, I'm going to do the arithmetic up here. 8 times 100 is 800, and then 8 times 30 is 240, and then 8 times 6 is 48. And so this is 1088. And then 1088 plus 1 is 1089. Okay, I'm going to do another thing here. I'm going to replace the 1 plus 8 times 136 with 1089, because 1 plus 1088 is 1089. But notice that one of the solutions is negative. The one that we get by subtracting is negative, but in the context of the problem, a negative answer doesn't make sense. So I'm just going to write down the answer we get when I write negative 1 plus the square root of 1089 divided by 4. And the square root of 1089 is just 33. So it's negative 1 plus 33 divided by 4. Negative 1 plus 33 is 32. 32 divided by 4 is 8. Okay, so if we go with x equals 8, then the height of the triangle is 8 feet. 8 feet. And the base is 4 times 8 plus 2. 4 times 8 is 32. 32 plus 2 is 34. So the base is 34 feet. And you can verify that the area is 1/2 base times height. So sure enough, 1/2 times 8 times 34. 1/2 times 8 is 4, and 4 times 34 is 120 plus 16, or 136. Okay, so it all checks out. Okay, we'll move on to the next problem. Okay, problem number 3. So we have a work problem on this one. Working together, Bertram and Florence can clean their shop in 2 hours. When each works alone, Florence takes 3 hours longer than Bertram. Find how long it takes each to clean the shop alone. Okay, so this is a work problem. Equations have the form rate times time equals 1 for work problems. Okay, so we're going to have three situations. Bertram works by himself. Florence works by herself. And then they work together. Okay, so we're going to do what we've always been doing so far this semester with work problems. The first information given is how long it takes them when they work together. So when they work together, Bertram works at a certain rate, Florence works at a certain rate, and in 2 hours they can clean the shop. So rate times time equals 1. When each works alone, Florence takes 3 hours longer than Bertram. So if I pick X to be the amount of time it takes Bertram, then Bertram's rate times X hours equals 1. So X represents, you can use any variable you want. Okay, and then Florence takes 3 hours longer than Bertram. So Florence will take X plus 3 hours because it's 3 hours longer than Bertram. Okay, so for each of the three scenarios, we have equations, each having the form rate times time equals 1. So we'll solve each of the equations for the rate. Bertram's rate is 1 over x. Florence's rate is 1 over x plus 3. And Bertram's rate plus Florence's rate is 1/2. Okay. Then replace Bertram's rate with 1 over x. So we get 1 over x plus Florence's rate, which is 1 over x plus 3. And the sum of the two rates is 1/2. Okay, we learned how to solve equations like this in chapter 7. This is an equation with rational expressions. The variable that we want to solve for is in the denominator. Okay, so we identify the least common multiple of the denominators, which is called the least common denominator. It's just 2 times x times the binomial x plus 3. And if it helps, you can write this as over 1. Okay, we have quite a bit of experience multiplying every term on both sides of an equation by a least common denominator. So I'm not going to write all of the detail that I could. I'm just going to point out when we multiply 2x times x plus 3 times 1 over x, the x's cancel each other. And so we'll just be left with 2 times x plus 3. And then when we multiply the least common denominator by the next term, 1 over x plus 3, the x plus 3 factors cancel, and we're just left with plus 2x. And then on the right-hand side, multiply 1/2 times the least common denominator. The 2's cancel, and then we're just left with x times the binomial x plus 3. Okay, so what we have is a quadratic equation. It's not yet in standard form, so that's what we're going to do next. We're going to do algebra and arithmetic and write it in standard form. So here on the left, multiply 2 times the binomial x plus 3 to get 2x plus 6. And then we're adding 2x. On the right-hand side, multiply x times the binomial x plus 3, and we get x squared plus 3x. Okay, we'll go ahead and combine like terms on the left-hand side. 2x plus 6 plus 2x simplifies to 4x plus 6 equals x squared plus 3x. And next, I will subtract 4x from both sides and subtract 6 from both sides. And the left-hand side will be 0. The right-hand side, x squared minus 1x minus 6. Okay, so here is our quadratic equation in standard form. We can use the quadratic formula. You can always use the completing the square method. But we can solve this one by factoring. We can pretty easily factor x squared minus x minus 6. So one of the factors is x minus 3, and the other factor is x plus 2. And if you're ever in doubt about your factoring, you can always multiply the factors. But yeah, this checks out. Just observe, negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Yeah, so that checks out. This quadratic equation has two solutions. One is positive 3. The other one is negative 2. Okay, but in the context of the problem, the positive solution is the only one that makes sense. So x equals 3, that means Bertram's time is 3 hours. So in other words, it takes him 3 hours to clean the shop by himself. And Florence takes 3 hours more than that. So Florence's time is 3 plus 3, or 6 hours. Hey, you could, if you want, you could go into more detail. You could verify that Bertram's rate, which is 1 over 3, in other words, he can clean 1/3 of the shop per hour. And Florence's rate is 1 over 6. If you want to just be absolutely certain that you have the right numbers, you can replace Bertram's rate with 1/3, add it to Florence's rate, which is 1/6, and verify that 1/3 plus 1/6 equals 1/2. And it certainly does. 1/3 plus 1/6, common denominator is 6, so rewrite 1/3 as 2 over 6. 2 over 6 plus 1 over 6 is 3 over 6, and 3 over 6 is 1/2. So that verifies that we have the right numbers. Okay, let's move on to the next problem. Okay, in a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. So what this means is that during a 5-hour period, the airplane flew a total of 600 miles, but half of it, 300 miles, was with the wind, and the other half was against the wind. If there is no wind, the airplane flies at 125 miles per hour. So we're going to find the speed of the wind. Okay, so this is sort of a ridiculous problem because we know that wind isn't constant. The wind doesn't always blow at the same speed, and it can change directions. But we're going to assume that the wind speed is always the same, regardless of when the airplane flies into the wind or with the wind. Otherwise, we couldn't solve the problem. Okay, so this is a problem that involves equations of the form rate times time equals distance. And we have two scenarios to consider. One is when the airplane flies with the wind. Okay, so when the airplane flies with the wind, well, if there was no wind, the airplane would be flying at 125 miles per hour. But if it's flying with the wind, it's going to be going faster than 125 miles. And it's going to be going faster by whatever the wind speed is. So we're going to pick a variable to represent the wind speed. So I'll just pick x to be the wind speed in miles per hour. Okay, so the rate of the plane when it's flying with the wind is going to be the speed that it would fly if there was no wind plus the wind speed. And I'll just represent the time as t sub w for flying, the amount of time it takes to fly a distance of 300 miles with the wind. Okay, the other scenario is when the airplane flies against the wind. Hey, if there was no wind, the airplane would be flying at 125 miles per hour. But if it's flying against the wind, the airplane will be going slower than 125 miles per hour. It will be going slower by whatever the wind speed is, and we're using x to represent the wind speed. So against the wind, the airplane is flying at 125 minus x miles per hour. And I'll write t sub a for the amount of time it takes to fly 300 miles against the wind. In the first part of the first sentence, we're told that the total amount of time is 5 hours. So the total amount of time to fly 300 miles with the wind combined with the amount of time it took to fly 300 miles against the wind is 5 hours. So that means t sub w plus t sub a is 5. So this is an important observation. So what we do is we solve each of these two equations for the time. So for this equation with the wind, the time it took to fly 300 miles with the wind is 300 divided by the rate, 125 plus x. Solve this for time. The amount of time it took to fly 300 miles against the wind is distance divided by rate, 300 divided by 125 minus x. And then the sum of the two times is 5. So we finally, when we replace t sub w with 300 over 125 plus x and add that to t sub a, which is 300 over 125 minus x, and the sum of the two times is 5, we finally have our equation whose only variable is x. Okay, and we learned how to solve equations like this in Chapter 7. It's an equation with rational expressions. The least common denominator is 125 plus x times 125 minus x. Okay, with a calculator, this isn't going to be much of a problem. So we're going to multiply both sides of the equation by the least common denominator. So when we multiply this by 300 over 125 plus x, the binomial factors 125 plus x cancel. So we're just going to be left with 300 times 125 minus x. And then we're going to add that to the next term when we multiply it by the least common denominator. So this next term, the 125 minus x factors cancel. So we're just left with plus 300 times 125 plus x. And then on the right-hand side, we multiply 5 times the product of 125 plus x times 125 minus x. Okay, so I'm going to go ahead and note what the product of this is. So follow this. 125 times 125 is just 125 squared, and then minus 125x, and then plus 125x. Those cancel each other out, and then the other term is minus x squared. Okay, so for now, I'm just going to write it as 125 squared minus x squared. Okay, so we apply the distributive property. We get 300 times 125 minus 300x plus 300 times 125 plus 300x. And then, so notice what we have here. 125 is 5 to the third, and 5 to the third to the second is 5 to the sixth. So I'm just going to write 5 times 5 to the sixth as 5 to the seventh, and then minus 5x squared. So we can deal with the actual numbers later. But notice over here the x terms cancel each other out. The minus 300x and the plus 300x, they cancel each other out. And then we're just left with 300 times 125 plus 300 times 125. So I get 2 times 300 times 125, and I can write that as 600 times 125 equals 5 to the seventh minus 5x to the second. Okay, this might look crazy, but we'll take it a little bit further. Let's get this into standard form by adding 5x squared to both sides and subtracting 5 to the seventh. And so we'll get 5x to the second plus, this is already over there, plus 600 times 125, and then minus 5 to the seventh equals 0. And then we can divide every term by 5 to simplify a little bit. 5x to the second divided by 5 is x squared. So when you divide this by 5, make sure that you only take a factor of 5 out of one of those. So I'm going to take a factor of 5 out of 125. So when I divide 600 times 125 by 5, I'm just going to get plus 600 times 25. And I also have to divide 5 to the seventh by 5, so this just becomes minus 5 to the sixth. Okay, so I'm going to leave the rest of this to you, for you to do, because all you have to do, since there's the only term that has x in it is x squared, you can subtract 600 times 25 from both sides and add 5 to the sixth. And then you can use the square root property. So let's see. I'll write it one more step for you. So we have the x squared plus 600 times 25 minus 5 to the sixth equals 0. So you can see that. So we'll just put all of the numbers on one side. So I'll write 5 to the 6th and then minus 600 times 25. And you can use a high-powered calculator to simplify that to an actual number. And then x, you want the positive solution, so just pick x to be the square root of that number, whatever that number is. I could take a couple of minutes and find it, but I want to move on to other problems. So this is not really so bad with a calculator. Hey, we do want to see other examples. So this one, the area of a rectangle is 75 square feet. Its length is 2 more than 3 times the width. Find the length and the width. Okay, so for a rectangle, sometimes it helps to draw a rectangle, and the area of a rectangle is length times width. So the length is described in terms of the width. So a strategy that I like is, since the length is described in terms of the width, I'll just pick a single variable for the width. So the width is x feet, and the length is 2 more than 3 times the width. So 3 times the width is 3x, and 2 more than that is 3x plus 2. So you don't need to draw a diagram, but it might help. X is the width, and the length is 3x plus 2. And the area is length times width. Area of a rectangle is length times width. So for this one, the area is 75 square feet, and length times width is 3x plus 2 times x. So we can get it into standard form. 3x plus 2 times x is 3x squared plus 2x, and then we'll subtract 75 from both sides, and we get 0 equals 3x squared plus 2x minus 75. Okay, so let's use the quadratic formula. So a is 3, b is 2, c is negative 75. So x is equal to negative 2 plus and minus the square root of 2 squared minus 4 times 3 times negative 75, all divided by 2 times 3. So we get negative 2 plus and minus the square root of some number, all divided by 6. Okay, so inside the square root, 2 to the second is 4, and we're subtracting 4 times 3 times negative 75. Okay, so 4 times 3 times negative 75 is just negative 900. So 4 minus negative 900 is 4 plus 900. So we get negative 2. Once again, the solution we get by subtracting doesn't make sense, so this is going to be plus the square root of 904 divided by 6. Okay, so use your high-powered calculator, find the square root of 904, and then add negative 2 plus that number and divide it by 6. And that will be the width of the rectangle. And the length is 3 times x plus 2. Okay, let's try this next one. The height h in feet of a projectile shot upward is h equals negative 16 t to the second plus 80t plus 96 after t seconds. So find the number of seconds it takes for the projectile to hit the ground. Okay, well, h represents the height of the projectile above the ground. So when the projectile hits the ground, the value of h will be 0. So to find the number of seconds t it takes for the projectile to hit the ground, we just replace h with 0, set it equal to negative 16t to the second plus 80t plus 96. And then we solve this equation for t. This is a quadratic equation in the variable t. So we know how to solve any quadratic equation. We can always use the quadratic formula. But I'll show you something to always try to keep in mind when solving quadratic equations. We can get rid of a bunch of the clutter that's in the way because 16 is a common factor of negative 16, 80, and 96. So what I like to do in a case like this, when it works out so nicely, is to divide every term on both sides by negative 16. Because if possible, I want, in my quadratic equation, I want the coefficient of the squared term to be positive. So we can always do that with a quadratic equation. So we're going to divide every term on both sides by negative 16. 0 divided by negative 16 is still 0. Negative 16t to the second divided by negative 16 is positive 1t to the second, or just t to the second. And then positive 80t divided by negative 16 is negative 5t, but here we write minus 5t. And 96 divided by negative 16 is negative 6, so we write minus 6. So this equation looks a lot easier to solve, but the solutions to each of those two equations are the same. And we can easily solve this one by factoring. One factor is t minus 6, and the other one is t plus 1. One solution to this quadratic equation is positive 6. The other solution is negative 1. But in the context of the problem, the only solution that makes sense is the positive solution. So you can summarize this by saying it takes 6 seconds after being fired for the projectile to hit the ground. So it takes 6 seconds for the projectile to hit the ground. Okay, we're also going tomorrow in this section, the 8 a.m. section, the P1 section. We're going to do more problems from section 9.5. And so I think we'll just stop for now since there's just a little bit more than 1 minute left for today. And remember the quiz on Friday. Not tomorrow, but on Friday, the quiz. So you can start practicing for the quiz by reviewing how to solve quadratic equations. Okay, so that's all for today. We'll start in 1 minute. Today we're going to cover section 9.5 on applications with quadratic equations. For quiz 9 on Friday, review how to solve quadratic equations using a valid method. If you can solve the equation by factoring, then you're free to do so. You can always use the completing the square method, and you can always use the quadratic formula. Just be mindful that not all quadratic expressions can be factored with integer coefficients. So in those cases, you'll want to use either the completing the square method or the quadratic formula. And we'll have the quiz Zoom proctored. It'll start at about 9:40 a.m. And I'll send information about the Zoom meeting. Okay, so let's go ahead and start section 9.5. First, we'll discuss some problem-solving strategies. These are not unique to this particular section, but they work in general. So the problem-solving strategy, step 1, read the problem, and then endeavor to understand the words and the ideas. So if you don't understand what the problem is about, then there's not much of a chance that it can be solved. After you have come to understand as much as you can, then identify what needs to be found. Usually that's pretty obvious if you look closely enough. And then pick a variable to represent each quantity that needs to be found. Oftentimes, and we've seen this in some of our previous work, that you don't need to pick two different variables. You can pick a variable to represent one quantity and then use the same variable when you describe the other quantity, because information is often given that relates the two quantities. And I'll point that out when we work on problems today. Using the variables, the variable assignments, and the given information, then formulate an equation. And then solve the equation using algebraic properties. And then check the answer and verify that it makes sense. You'll get some solutions that just won't make sense in the context of the problem, and you should only use the solutions that make sense. I'll point that also. Okay, so we'll start our first problem. This one, the product of two consecutive positive odd integers is 143. Find the integers. Okay, so some of the details. Two consecutive positive odd integers. An example of a pair of consecutive positive odd integers are 9 and 11. There are infinitely many other pairs, but that's just one example. And since we don't know what those are yet, we can pick x to be one of those integers. And consecutive odd integers differ by 2, so x can represent one of those, and the other one can be represented by x plus 2. Okay, so this is what I was referring to a minute ago. We have two quantities, but I'm using the same variable in each of those quantities. One is just x, the other one is x plus 2. This is generally easier if you can do it rather than having two different variables. Okay, we're told that the product of those consecutive odd integers is 143. So this is where we formulate an equation based upon our variable assignments and the information given in the problem. The product is what you get when you multiply. So we multiply x times the binomial x plus 2, and the product is given to be 143. Okay, so this is just a quadratic equation. It's not in standard form. And so we can get it into standard form. First, we'll multiply x times the binomial x plus 2, and we get x to the second plus 2x equals 143. Okay, so at this stage, we start to decide what method to use to solve this quadratic equation. It looks like it's set up pretty nicely to use the completing the square method because the coefficient of x squared is already 1, positive 1. The x squared term and the x term are also on one side and the number is on the other. So I'm just going to go ahead and apply the completing the square method. So we're going to add a number to both sides so that the left-hand side is a perfect square trinomial. So the way that we do that, since the coefficient of x squared is 1, we take 1/2 of the coefficient of x. 1/2 times 2 is 1. And then we square that number. 1 squared is 1. So we add 1 to both sides. And now the left-hand side is a perfect square trinomial. And it's easy to factor. X squared plus 2x plus 1. It's equal to x plus 1 times x plus 1. But we want to write it as x plus 1 squared. And then the right-hand side is 144. And now we can apply the square root property to solve this equation. Since x plus 1 quantity squared equals 144, we can write x plus 1 equals positive and negative square root of 144. And in the next step, I'll do two things at once. I'll subtract 1 from both sides and also simplify the square root of 144, which just simplifies to 12. Okay, so x equals negative 1 plus and minus 12. The quadratic equation that we just solved has two solutions. One is negative 1 minus 12, which is negative 13. And the other solution is negative 1 plus 12, which is positive 11. Okay, but let's go back and read what we're supposed to find. We want to find two consecutive odd integers that are both positive. So that means we're not going to use the negative solution because it's only asking for positive odd integers that are consecutive. So x equals 11 is one of the numbers, and the other number, x plus 2, is 13. So 11 and 13 are the two integers that we're trying to find. And then you can verify easily enough. These are obviously odd integers, and they are consecutive odd integers. And the product, 11 times 13, is 143. So everything checks out. Okay, let's move on to the next problem, number 2. The area of a triangle is 136 square feet. The base is 2 feet longer than word "the" shouldn't be there. The base is 2 feet longer than 4 times its height. Find the base and height of the triangle. Okay, what you need to know going into this problem is that the area of a triangle, so I'll just draw a random triangle. So for any triangle, we can pick any one of the 3 sides to be the base, and then corresponding to a base is what is called the height. So that this line segment that's perpendicular to the base is called the height. And there are always 3 options for how to assign a base and a height. But in this picture, it looks more natural to pick the bottom side as the base so that the height is perpendicular to the base. So the area of any triangle is 1/2 times the base times the height. Okay, so we have a particular triangle. We're told that its area is 136 square feet. And the base is described in terms of the height. The base is 2 feet longer than 4 times the height. So a general strategy, if one quantity is described in terms of the other, then I pick a variable to represent the quantity that's used to describe a different quantity. So since the base is described in terms of the height, I'm going to pick a single variable for the height. So the height is x feet. And then I use the information in the second sentence to come up with an expression for the base. The base is 2 feet longer than 4 times the height. Okay, 4 times the height is 4x, and 2 feet more than that is 4x plus 2. And then you can stand back and look at your variable assignments and read the information again and make sure that it makes sense. Okay, it seems to make sense. The base is 2 more than 4 times the height. Okay, now we can use the area of a triangle formula. We're given that the area is 136 square feet, and that's equal to 1/2 times the base times the height. The equation we have is just a quadratic equation in the variable x. It's not in standard form, but we can get it into standard form. Here we have a couple of options. What I'm going to do is I'm going to multiply 1/2 times the binomial 4x plus 2. So I get 136. And then since we're multiplying this quantity times x, I have to, when I multiply 1/2 times the binomial, I still have to have a binomial because I'm multiplying it by x. So 1/2 times 4x is 2x, and 1/2 times 2 is 1. So I have the binomial 2x plus 1 times x. Okay, now we'll expand this. 2x plus 1 times x is 2x squared plus x. And then we'll write the quadratic equation in standard form by subtracting 136 from both sides. So I'll just write that here as 2x to the second plus x minus 136 equals 0. Okay, why don't we use the quadratic formula to solve this? So this is now in standard form, so a is 2b B is positive 1, and C is negative 136. Okay, so x equals negative 1 plus and minus the square root of 1 to the second minus 4 times 2 times negative 136, all divided by 2 times 2. And then we do some arithmetic inside the square root. So we have, before proceeding, well, I'll wait until we do a little bit more work here. Negative 1 plus and minus the square root of some number divided by 2 times 2, or 4, which is 4. So inside the square root, 1 squared is 1, and we're subtracting 4 times 2 times negative 136. So if we subtract a negative number, that's equivalent to adding a positive number. So I'm just going to write plus, 1 plus, and then 4 times 2 times 136. Okay, so that's, let's see, 8 times 100 is 800, and then plus 240, and then plus 48. So it's 1 plus 1088. And then 1 plus 1088 is 1089. So here I'll point out that the solution that we get by subtracting makes the solution negative. And in the context of the problem, we don't want a negative solution. We want a positive solution. So I'm just going to write down the solution we get by adding negative 1 plus the square root of 1089, all divided by 4. And the square root of 1089, well, we know what that is. That's just 33. So negative 1 plus 33 divided by 4. You're allowed to use your high-powered calculator to find the square root of that. And then in the numerator, negative 1 plus 33 is 32. And then 32 divided by 4 is 8. Okay, so we can go up here and we can say, well, the height is x equals 8. So x equals 8 feet is the height of the triangle. And 4 times 8 plus 2, which is 34 feet for the base. And then you can verify that those two numbers, 8 and 34, work in the problem. So the area of the triangle is 1/2 times the base times the height. So 1/2 of 34 is 17. And 17 times 8, sure enough, that's 136, which is the area. And if you want to verify that 34 is 2 more than 4 times 8, well, that's pretty easy. 4 times 8 is 32, and 2 more than 32 is 34. So everything checks out on this one. Okay, we'll move on to the next problem. Okay, this one, number 3. Working together, Bertram and Florence can clean their shop in 2 hours. When each works alone, Florence takes 3 hours longer than Bertram. Find how long it takes each to clean the shop. Okay, this is a work problem. We've seen these kinds of problems before. Equations have the form rate times time equals 1. Where 1 represents the job or the task that is being accomplished. Okay, so we'll have 3 scenarios. Bertram works by himself. Florence works by herself. and then they work together. In the first sentence, we're told how much time it takes when they work together. So we'll write down the equation Bertram's rate plus Florence's rate times 2 hours equals 1 job accomplished. Rate times time equals 1. We're not told specifically how long it takes Bertram by himself and how long it takes Florence by herself. So that's where the variable assignments come in. We are told that Florence takes 3 hours longer than Bertram. So for Bertram, I'll write down his rate, and then I'll pick a variable to represent the amount of time it takes Bertram to do the job by himself. So I'll just pick X. You can pick any variable you want, but I'll pick X. And since Florence takes 3 hours longer than Bertram, then Florence, the amount of time it takes Florence is represented by X plus 3. Okay, so we have 3 equations, each having the form rate times time equals 1. So just like other problems of this sort that we've done this semester, we solve each of the equations for the rates. Bertram's rate is 1 over X. Florence's rate is 1 over X plus 3. And Bertram's rate plus Florence's rate is 1/2. Okay, then replace Bertram's rate with 1 over X. Add that to Florence's rate, which is 1 over X plus 3. And the sum of the 2 rates is 1/2. Okay, well, we learned how to solve equations like this in Chapter 7. The variable that we want to solve for is in the denominator. So if we multiply every term on both sides by the least common denominator, we will be able to clear the denominator. So the least common multiple of the denominators is 2 times X times the binomial X plus 3. And if it helps, you can think of that as being over 1. Okay, we've done this enough that we don't need to write down every single detail. So we'll just point out what's going on. When we multiply the least common denominator by 1 over X, the X factors cancels. So that means we'll just be left with 2 times X plus 3. And then when we multiply 1 over X plus 3 times the least common denominator, the binomial X plus 3 cancels with 1 from the numerator, 1 from the denominator, and we're just left with plus 2X. And then on the right-hand side, 1/2 times the least common denominator. The 2 divided by 2 cancels, and we're just left with X times X plus 3. This equation is a quadratic equation. It's not in standard form, but we'll get it into standard form. So on the left-hand side, multiply 2 times the binomial X plus 3. We get 2X plus 6, and then plus 2X. And on the right-hand side, we multiply X times the binomial X plus 3. We get X squared plus 3X. Okay, so in the next step, I'll do a bunch of things at once. Notice on the left-hand side, if we simplified that, it would be 4X plus 6. So I'm going to subtract 4X from both sides and also subtract 6 from both sides. And we'll get 0 equals X squared minus X minus 6. This quadratic equation is now in standard form. So we can use the quadratic formula. We can use completing the square. But since this is easily factorable, we can also solve by factoring. So I'm going to solve this by factoring. One of the factors is X minus 3. The other factor is X plus 2. And then you can always verify that you factored correctly. It's especially easy when the coefficient of X squared is 1. So you can just look, negative 3 times positive 2 is negative 6, and negative 3 plus 2 is negative 1. So everything checks out. This quadratic equation has two solutions. One is +3, the other one is -2. Okay, but in the context of the problem, the negative solution doesn't make sense. So x equals 3, that means Bertram's time, I'll just say Bert's time, is 3 hours to do the job by himself. Florence takes 3 hours longer, so I'll just refer to her as Flo. Flo's time is 3 + 3, or 6 hours. Okay, and if you want, you can verify even doubly that those are the right numbers. So Bertram's rate, since it takes him 3 hours, Bertram's rate is 1/3 of the job per hour, and Florence's rate is 1/6 of the job per hour. And then in this equation, you can replace Bertram's rate with 1/3, add that to Florence's rate, which is 1/6. And it's not hard to verify that 1/3 plus 1/6 equals 1/2. So everything checks out on this one. Okay, I'm going to wait for a bit to do this problem, and hopefully we'll be able to come back to this one. But first, let's look at this problem, number 5. The area of a rectangle is 75 square feet. Its length is 2 more than 3 times the width. Find the length and the width of the rectangle. Okay, so for rectangles, we know that the area of a rectangle is length times width. We're given the area of a rectangle, and we're told how the length and the width are related. So the length is described in terms of the width. So my general strategy is to pick a variable for the quantity that is used to describe another quantity. So since the length is described in terms of the width, I'm going to pick a single variable to represent the width. And then the length is 2 more than 3 times the width. So 2 more than 3 times x is 3x plus 2. 2 more than 3 times the width. Okay, so that seems to check out. And we're given that the area is 75 square feet. So we can write down our equation. The area is 75 square feet. The length is 3x plus 2 feet. The width is x feet. So we just have a quadratic equation. So we'll get it into standard form. 3x, the binomial 3x plus 2 times x is 3x to the second plus 2x. Then we'll subtract 75 from both sides, and I'll put the non-zero terms on the left-hand side. 3x squared plus 2x minus 75 equals 0. Okay, so we have quadratic equation in standard form. I guess we could use the quadratic formula. We could probably solve it by factoring, I suspect, but let's use the quadratic formula where a is 3, b is 2, and c is negative 75. Okay, so now x equals negative 2 plus and minus the square root of 2 to the second minus 4 times 3 times negative 75, all divided by 2 times 3. Okay, I realize that this trinomial is not factorable with integer coefficients. Okay, so now let's just do the arithmetic. -2 plus and minus the square root of some number, all divided by 6, because 2 times 3 is 6. Okay, so inside the square root, 2 squared is 4. And we're subtracting 4 times 3 times -75, which is equivalent to adding 4 times 3 times +75. So it's going to be plus something. And so 12 times 75, I wonder what that is. Well, note, one thing you can do, 12 times 75 should be 3/4 of 12 times 100. 12 times 100 is 1200, and 3/4 of 1200 is 900. So we have 4 plus 900 inside the square root. You don't have to do it that way. You're allowed to use a calculator. So move on. Notice that the solution to this equation we get by subtracting is negative. And in the context of the problem, a negative solution doesn't make sense. So I'm just going to write -2 plus the square root of 904, all divided by 6. We can simplify the square root of 904. So 4 is a factor of 904. That's a perfect square. 4 times 226 is 904, and the square root of 4 is 2, so we can write -2 plus 2 times the square root of 226, all divided by 6. And then if we cancel one factor of 2 from the numerator and denominator, we get -1 plus the square root of 226 divided by 3. Okay, so in a case like this, if you have this problem in Newton, it will probably say to round the answer, using a calculator, round the answer to the nearest 10th or maybe the nearest 100th. So make sure that you know how to round decimal numbers to the appropriate number of places. Okay, the next problem, number 6. The height h in feet of a projectile shot upward is h equals -16t to the second plus 80t plus 96 after t seconds. Okay, so just to reiterate, h represents the height of the projectile t seconds after it's fired upward. So at the instant that the projectile is fired upwards, in other words, when t equals 0, the projectile is already 96 feet above the ground. So that's conceivable if you are on top of a tall building, 96 feet tall, and you shoot a projectile straight up, well, you're already 96 feet above the ground. So the question is, find the number of seconds it takes for the projectile to hit the ground. Okay, so if we assume that there are no obstacles in the path of the projectile, after firing the projectile upwards, then it's only a matter of time until it hits the ground. When it hits the ground, its height above the ground is 0 feet. So to solve this problem, we replace h with 0, because when the projectile hits the ground, its height above the ground is 0 feet. We set 0 equal to -16t to the second plus 80t plus 96. This is a quadratic equation in the variable t. We know how to solve any quadratic equation. But with a little practice, you'll know how to make the solving of that equation, or of an equation, simpler. At least in some cases, you'll be able to make it simpler, like in this one. Notice that negative 16, 80, and 96 are all multiples of 16. And then another thing that I've mentioned before, you can always, when solving a quadratic equation, you can always arrange it so that the coefficient of the squared term is positive instead of negative. It will make the arithmetic simpler. So if we divide every term on both sides by negative 16, we'll get an equation whose solutions are exactly the same as this equation, but it will be a lot easier to work with. So we'll divide every term on both sides by negative 16. 0 divided by negative 16 is still 0. Negative 16t to the second divided by negative 16 is positive 1t to the second, or just t to the second. Positive 80t divided by negative 16 is negative 5t. So here we write minus 5t. And 96 divided by negative 16 is negative 6. So we write minus 6. And we can easily solve this equation by factoring. But if you can always use the quadratic formula also. So one of the factors is t minus 6. The other factor is t plus 1. And so this equation has two solutions. One is t equals positive 6. The other one is t equals negative 1. So the solution that makes sense in this problem is the positive solution. So in other words, it takes the projectile 6 seconds to hit the ground after it's fired upwards. So 6 seconds. Okay, we'll move on to the next problem, number 7. Okay, this one says a pole that is perpendicular to the ground casts a shadow whose length is 1/3 the height of the pole. The distance from the top of the pole to the edge of the shadow is 20 feet. Find the height of the pole and the length of the shadow. So I don't know why anyone would want to do this, but let's sketch a diagram. Suppose this is the pole that's perpendicular to the ground. Perpendicular to the ground. Okay, and what are we told? Let's see, the shadow, the length of the shadow was 1/3 the height of the pole. So this is the pole, so its height, and then the shadow, this won't necessarily be to specifications, but let's suppose this is the shadow of the pole. So the sun is up here somewhere. Okay, then we're told that the distance from the top of the pole to the edge of the shadow is 20 feet. So if we draw a line segment that connects the top of the pole to the edge of the shadow, we're told that that's 20 feet. Okay, find the height of the pole and the length of the shadow. Okay, so let's pick a variable for either the pole or the shadow, and then use the same variable and the information to describe the other quantities. So we're told that the shadow is 1/3 the height of the pole. So I'm going to do it this way. I'm going to pick x to be the shadow in feet, and the pole is 3 times that, since the shadow is 1/3 the pole. So 3x is the height of the pole. Okay, well, what we're working with here is just a right triangle. And let's just look at it this way. The pole is 3x feet. The shadow is x feet. And the line segment that connects the top of the pole with the edge of the shadow is 20 feet. So here we're just going to use the Pythagorean Theorem. So I'll just remind you, we've seen this before. If you have a right triangle, if the length of the hypotenuse is c units and the lengths of the two shorter sides are a and b, then if you square the length of the hypotenuse, that's equal to the sum of the squares of the two shorter sides. So we're going to apply the Pythagorean theorem to this right triangle, and that will enable us to solve for x. Okay, so square the hypotenuse, 20 squared, and that's equal to the term 3x squared plus x squared. 20 squared is 400. Here you have to make sure you're careful. When you square 3x, you get 9x squared, and then plus x squared, which is a total of 10x squared. So what we can do now is just divide both sides by 10. 400 divided by 10 is 40, so I get x squared equals 40. Okay, then we want the positive square root of 40, since the quantities have to be positive. So x equals the positive square root of 40. And that can be simplified to 2 times the square root of 10. Okay, so the length of the shadow is 2 times the square root of 10 feet. And the height of the pole is 3 times that. So that's 3x is 6 times the square root of 10 feet. So you can use a calculator to get a decimal approximation of 6 times the square root of 10 and also 2 times the square root of 10. Okay, we'll go ahead and move back to the one problem that I postponed. So this one, in a total of 5 hours, an airplane flies 300 miles with the wind and 300 miles against the wind. Okay, so make sure that you catch what it's saying. The airplane flew 300 miles with the wind, and then after that flew 300 miles against the wind, and the total amount of time to fly those 600 miles was 5 hours. If there is no wind, with no wind, the airplane flies at 125 miles per hour. So find the speed of the wind. Okay, this is a uniform motion problem. Equations have the form rate times time equals distance. So the clues in the problem, there are distances described, 300 miles. Rates or speeds, 125 miles per hour is a speed, and time. So it's pretty clear that rate times time equals distance is involved. There are 2 scenarios described. The airplane flies with the wind in one case, and against the wind in the other. We're supposed to find the speed of the wind. Okay, so that's the only quantity we're supposed to find, so we'll just pick x to be the wind speed in miles per hour. Okay, if the airplane is flying with the wind, and the airplane, if there is no wind, the airplane flies at 125 miles per hour. So when it's flying with the wind, it's going to be going faster than 125 miles per hour by the wind speed, which is x miles per hour. Okay, so the rate of the plane with the wind is 125 plus x. And for its time, I'm just going to use t sub w to represent the amount of time it takes the airplane to fly 300 miles with the wind. Okay, but when the airplane flies against the wind, it will be traveling slower than 125 miles per hour. It will be traveling slower by x miles per hour, which is the wind speed. So if it's flying against the wind or into the wind, the plane is traveling at 125 minus x miles per hour. And I'll use t sub a for the amount of time it takes to fly 300 miles against the wind. Okay, then all of the observations are important, but a really important observation is that the total amount of time is 5 hours. So in other words, the time to fly 300 miles with the wind plus the amount of time to fly 300 miles against the wind is a total of 5 hours. So that is also equally important to observe. So what we do is solve each of these two equations for time, substitute those quantities into this equation, and then proceed to solve for x. So the time it takes to fly 300 miles with the wind is distance divided by rate, 300 divided by 125 plus x. And the amount of time it takes to fly 300 miles against the wind is distance divided by rate, 300 divided by 125 minus x. And then in this equation, t sub w plus t sub a equals 5, we replace t sub w with 300 over 125 plus x. We add that to the other amount of time, which is 300 divided by 125 minus x, and the total is 5 hours. Okay, so we learned how to solve equations like this in Chapter 7. The least common multiple of the denominators is just 125 plus x times 125 minus x. So let's just observe what's going to happen. 125 times 125. 125 is 5 to the third. So 5 to the third times 5 to the third is 5 to the sixth. I'd rather write 5 to the sixth at this point as opposed to the big long number that it would be if I did that. Okay, but then after that, 125 times negative x and then plus x times 125, those two terms cancel each other out. So we're just left with minus x squared. Okay, but we're going to multiply every term on both sides of this equation by the least common denominator. First, when we multiply 3 over 125 plus x times the least common denominator, the 125 plus x factors cancel, and we're just left with 300 times 125 minus x. And then plus, when we multiply the least common denominator by 300 over 125 minus x, the 125 minus x factors cancel, and we'll just be left with 300 times 125 plus x. And then we're going to multiply the right-hand side, 5, by the least common denominator. But I'm just going to multiply 5 times this quantity, 5 to the 6th minus x squared. 5 times 5 to the 6th is 5 to the 7th. You can use a calculator later to determine what 5 to the 7th is. And then we also have minus 5x to the 2nd. Okay, when you do the arithmetic, since we're about out of time, notice that the minus 300x and the plus 300x cancel, and we're just going to be left with 300 times 125 plus 300 times 125, which is a total of 600 times 125, equals 5 to the 7th minus 5x to the 2nd. Okay, as long as I have time, I'll just keep going. So in this one, there's only one term with a variable in it. So if I add 5x to the 2nd to both sides, I get 5x to the 2nd. And then I already have 5 to the 7th on this side, and then I'll subtract 600 times 125. In the next step, you can divide every term on both sides by 5 and then take the positive square root, and that will be the value of x. So it's not really hard. It just looks sort of complicated. But just keep working at this one and you'll get the answer. That's all for today.